warm up. What you're trying to do here is just read the question here, write each of these as the sine, cosine, or tangent of a single angle. And on number 4, you don't have to find, it's not asking you to do the whole problem because this is a long problem. All it's saying is find 2 angles that you would use for A and B in this problem. And it's saying A plus B there, yeah? Okay, off you go. Give you a minute. Okay, so when I look at number 1, can you see this is the same sine sandwich? You've got sines on the outside with cosines in the middle. So this is using the identity sine A times cos B plus cos A times sine B. That's what you've been given, and hopefully you recognize that as the identity, that all of that is the sine of A plus B. Same sign sandwich, the same. That plus there is the same as the plus there. So this just simplifies to the sine of, and look at it, what does our A match up with? A is 45, A is 45, and our B is 30. So where I see A, I write 45. Where I see A is 45 and the B is 30. Read the question. Write each as the sine, cosine, or tangent. Well, I've written as the sine, check, of a single angle. No, that's 2 angles. But we can do that now. It's just add them up. 45 plus 30 is 75 degrees. So now I've finished. Sometimes we ask a question that doesn't say just that. It might just say simplify. That's simplified. Sometimes we say evaluate. When we say evaluate, we want you to find the value. We want you to find the number. So you'd have to go on and find the sine, which is the y over r. So you'd need to draw a triangle. Well, 75 isn't one of our special angles, so you couldn't do it. We can only ask you to evaluate if the angle you're left with is based on a 30, 60, 90, 45, 45, 90, or if it's quadrantal, okay? That's when we can ask you to evaluate those ones. This one, you couldn't evaluate it. You couldn't get an exact answer. You'd need a calculator, and we don't give you those, okay? So just point out the difference in the questions. Right, let's look at the next one. Again, oh no, we haven't been given the same sign sandwich. We've been given cosine of A times B plus sine of A times B. We've been given cosines change signs. This is the cosine of A and B, and cosines change signs. So where there's a plus, we'd have a minus. So what we've got here is we've got the cosine of 5 pi over 6 minus pi over 4. Yeah, it's like cos A times cos B plus sine A times sine B. That's the identity we were given there. So we've been able to write it as the cosine, but at the moment it's of 2 angles. So let's add those angles together. So adding fractions, the common denominator I'm going to use when I'm and this is work you can probably do in your head, so it doesn't need to be shown. I'm going to put them over a common denominator of 12. So that's being multiplied by 2 over 2. This one's being multiplied by 3 over 3. So I've got 10 pi minus 3 pi. I've got 7 pi all over 12. Did you need to show that work with fractions? Nah, that's middle school. You don't even show that, okay? Unless you're going to get it wrong and want me to give you some credit for the work, yeah? If you get it wrong, I can't give you any credit for the work if you didn't show it. And this one again, we've got cosine of A times cosine of something different, call it B, Sine of A times sine of B. That's the identity. Cosines change signs. It's the identity. Cosines change. So what we're looking at here is the cosine of, match it up. Our A is 3 theta. Plus, we could have picked it from here if we wanted to. Either of those places would do. Our B, I could pick it here, or there. It's just 1 theta. So what we've got here is the cosine of, do this math here, 3 theta plus theta is 4 theta. Okay, so that was number 3. Now, I can't give you the right answer to number 4 because there's an infinite number of right answers. Okay, we're looking for, oh, this is pi over 12. That's a small angle. It's half of pi over 6. So it's half of 30 degrees, 15 degrees. And I'm going to get it by adding 2 things. So this second thing is going to have to be negative. Yeah, to get something small, I'm not adding 2 even smaller things because none of our special angles are smaller than that. So I'm going to have to get it by adding the negative. And there's 1,000 choices. You could be a very strange person and choose this, but none of you chose this combination. Does that give me 5 as well? Yeah. I bet you didn't choose those. Now let's look at what I've written here. 3 goes into 27 9 times. And 3 goes in there. I did 9 pi over 4 minus 2. 13 pi over 6. Oh, plus negative. Ooh. Wow, that was wrong with me. I bet you didn't do that, did you? The most sensible would have been to use like 4 pi over 12 plus negative 3 pi over 12, or maybe, which is like pi over 4 plus negative, no, plus pi over 3. Or you could have used 3 pi over 12 plus negative 2 pi over 12. All of these are giving you pi over 12. The question says, identify which angles you would use for your A and your B. If I was doing this one, there's my A, there's my B. My A equals pi over 4, and my B equals negative pi over 6. Okay, that's that one. But there's no right answer. There's no one right answer to this. Infinite number of right answers. If you come up with that one, you're a very strange person and deliberately did something really weird. Okay, let's move on. This is a bit of a lesson we didn't do yesterday. When you see the word verify, remember what that means. It means that what we've been given isn't just any old equation. It's an identity that's got to be true for all values of the variable. The variable in this is here. The variable is beta. So we have to prove this equation is true for every single value of beta that could go in there. That's part of the domain. So what you have to do is the layout of your work is critical. You can't randomly lay this out. You have to show that you're working with one side of the equation or the other. So where that equal sign is, exactly underneath it, draw an equal sign. You can't do a bit to the right, a bit to the left. You have to show me which side you're working with. Then underneath this, well, this is the most complicated side. So I'm going to work with that side. So I'm going to be doing work on this side. I'm going to leave this side blank. Yeah? To show I'm working with the right. Now, this, when I look at it, I'm seeing cosine of A plus B. So I know I'm going to use this identity, but please don't write that in your work there. Because when you're doing these verifications, that's what you're thinking about. Normally we want you to write out the identity. But if you write that there, You are saying, I know that this equals this, and that's not true. You don't know that. So you can't write that there. Please don't. Okay, you're thinking about that. And we are, when you're writing out these identities, underneath this, directly underneath this, we're going to write something that it is equal to, that it can be replaced by. That's how you have to lay out your work. So, I'm going to say that cosine of A plus, cosine of something plus something can be replaced using this identity. So I'm going to be writing out this side, but where I see A, I'm going to be putting in a pi, and where I see B here, I'm going to be putting in beta. Okay? So underneath this, I'm going to replace it by what it's equal to. So that's cosines. Cosines change signs. So list the cosines, change that, and write the sines. And why I'm justifying doing that, I just had something that looked like this, and I replace it with something it's equal to that looked like that. That's the replacement you're thinking about, but you don't need to show that there. That doesn't need to be written in your work. Okay? Okay, now I've got to simplify that. Nowhere nearly at this yet. So what in this equation do I know? I know the value of this, and I know the value of that. If you can't remember what they are, go and do some work. Pi. The angle pi is here. Yeah? This is the angle pi. It's quadrantal. So I'm not going to draw a triangle. Instead, I'm going to draw a circle of radius r. And I'm going to use the coordinates of this point where that terminal ray cuts the circle to be able to work out the cosine of pi. And I'm also going to need the sine of pi. Cosine is x divided by r, sine is y divided by r. The circle had a radius of 1. So now all I need to know is the x and y coordinates of this point here. Its x is not 1, it's gone left. Its x is -1, and the y is not going up at all, its y is 0. So, in an equation where I see the cosine of pi is equal to and can be replaced by -1. So where I see the cosine of pi there, in its place I'm writing -1. Then that's been multiplied by the cosine of beta. I don't know anything about beta, so I can't do anything with it. Then I've got minus, and then I'm seeing the sine of pi. When I see the sine of pi, I can replace it with 0. Multiplied by the sine of beta. So now just do the math. -1 times cos beta is negative cos beta minus nothing. So I'm done. Now look at your layout. Is it obvious I just worked with the right side? Have I now got the right side to equal what's on the left? Yes. So bring down that thing from the left. Show you created identical twins, and you are done. Okay? Please be careful how you lay out your work. Oh, in your work, I really don't want that. Yeah, that was me talking about it. Yeah? Right, let's move on. Read that. Divide your page, if this is a page of your notes. Write this information and this information, and think that you're going to be working in 2 columns. That's how to lay out your work, okay? So write out that information and then read this. So, use the given information to identify the quadrant and to graph a triangle for angles alpha and beta. I'm going to color code this. I'm going to do one drawing for alpha, and I'll do that in pink. And I'm going to do one drawing for angle beta, and I'll do that one in blue. So I want to graph them, and I need to know what quadrant they're in. So these are going to be my graphs, one for alpha, one for beta. So I only want to draw one triangle. When I look at this, I've got to work out what quadrant I'm in. The tangent is negative. Remember, tangent is y over x. It's going to be negative if either one of the x or the y is negative, but not both. Or you can use Angry Santa. Angry Santa traumatizes children, tells you tangent is positive in 1 and 3. We want it to be negative. So the fact this tangent is negative is telling me I'm in quadrant 2 or quadrant 4. It's not enough information. Let's look at this. Aha! This is telling me I'm between 3 pi over 2. 3 pi over 2 is here, and 2 pi, which is here. So it's telling me I'm in quadrant 4. Ah, I could have just used that. Okay? So I know I'm in quadrant 4. Now, I don't know how big angle beta is, but I can draw the terminal ray for angle beta, and I can draw a triangle to describe it. Now, if we're honest about it, that's the easiest angle alpha could be. I mean, it's angle alpha, not angle beta. Or it could be this, or it could be this. It could be any angle that ends on that terminal ray. We don't know which one of those it is. We don't know anything about it. All we know is that this is a reference triangle for angle alpha. Let's label up the sides, and then we'll be able to find sine, cosine, tangent, or anything we wanted for angle alpha. This piece of information here tells us the y is 3, and the x is 4, and one of them is negative. Look at your picture, it's obvious. Must be, if you're in quadrant 4, it's the y that's negative, and hopefully you know that triangle. That's a 3, 4, 5 Pythagorean triple. But if you needed to, you could have used this to calculate alpha. Okay? Let's look at beta. This piece of information here, if the cosine is negative, cosines are x's over r's, you're going that way. You're in quadrant 2 or 3. One of those two. I want one quadrant out of that lot. Aha, this one is this question's too easy. Normally, the information we give you here is giving you 2 quadrants, and you have to see whether 2 overlap. I don't like this question. I need to reword it. This information is telling us we're between pi over 2 and pi. It's telling us we're in quadrant 2. So just draw a terminal ray. And again, all that terminal rays is where angle beta ends. We don't actually really know what angle beta looks like. There's many angles that end there. But this will do to describe angle beta for us. So make it into a triangle and label the lengths of the x, y, and the r. The fact that the cosine is negative 5 over 13, that's telling us this is the x, that's the r. The x is 5, the r is 13, and one of them is negative. Well, look at your picture, it's obviously the x that's negative. Okay, now we've got to find the y. Some of you might know this. This is a famous Pythagorean triple that we use often in tests and quizzes because it's easy for us. But if you don't know it, you have to work it out. So your x is negative 5, square that. 25 plus y squared equals 13 squared is 169. Y squared equals 169 minus 25 equals 144. Now be careful. I need to change this question. I really need to change this question. Y equals plus or minus the square root of 144. Sometimes you will want the minus, but look at this one. The y, this side is going up. Y equals positive 12. If this had been in quadrant 3, we would have had to use the negative square root. Watch out for that. While we're on this page, this is a Pythagorean triple. Like this one is a 3, 4, 5 triangle. This is what's called a 5, 12, 13 triangle. Those are two Pythagorean triples that you might have learned in geometry. We use them often. And if you see them, we like to fool you sometimes and put like 3 and 4 here, and people put 5 the third time. Oh gosh, sorry. We like to fool you with them. But there's many Pythagorean triples that we could use. We often use 3, 4, 5, and it's multiple. So double everything, you get a 6, 8, 10. Triple everything, you get a 9, 12, 15. We can ask you to do questions based on those without a calculator. The other one we can ask you, which we've just used, is this one. There's some other ones that are really famous that we sometimes use, but we're not going to ask you those without a calculator. But it's worth knowing they exist. 7, 24, 25, 8, 15, 17. But just to let you know that those are things that we sometimes throw in on text. But can we give you a triangle that's not a Pythagorean triple? Well, one of the sides ends up like being square root of 5. Yes, we can. And we will. So not everything turns out to be a nice number. Right, let's use those two problems those two angles we've just defined here. And we're going to do this. Find the exact value of, we're going to do the sine of tangent alpha minus beta, the tangent of alpha minus beta, and we're not going to be able to do that. There's something else I want to spend the time on in the lesson today. So this we've already drawn. You've already drawn it. It was minus 3, 4, 5. That was your information for alpha. And this was your information for beta. Okay, let's do these questions then. If I wanted to find the sine of alpha minus beta, pull over your identity, write out your identity. We're going to use the same sign sandwich with a minus in the middle. So write that out. And basically, I'm going to be a little lazy. A is alpha, B is beta. Look what we're going to need. We're going to need the sine of alpha, and we're going to need the cosine of alpha. And in a minute, we're going to do this question down here, the tangent of alpha minus beta. So by this picture, quickly work out the sine, cosine, and tangent of alpha. We're going to need them all. Sine of alpha equals, cosine of alpha equals, tangent of alpha equals. We're also going to need the cosine of beta and the sine of beta, yeah? And when we get to do the tangent problem, we'll need the tangent of it. So write these out. So sine is just a y divided by an r. It's -3 divided by 5. Please put the negative at the front. Your cosine is your x divided by your r, 4/5. And your tangent is your y divided by your x. So it's -3 divided by 4. Look, we were actually given that in the question. Then we're going to want the same for, oh, this isn't alpha, this is beta. Gosh, I'm having a bad day. Oops, sorry about that. Sine would be 12 over 13. Cosine would be the x divided by, oh, we were given that as well. And your tangent is the y divided by the x. Bring that negative to the front. Okay, right. So let's write this out then. What do we have here? Solve this question. We want something for the sine of alpha minus something for the cos of beta, multiplied by, minus something for the cos of alpha, times something for the sine of beta. Off we go. Fill it in, see what you get. I'm going to give you a minute. So your sine of alpha, when you see a sine of alpha, you're going to replace it with this. when you see the cosine of theta, you're going to replace it with this. Then you've got minus the cosine of alpha, which was 4/5, and the sine of theta, which is 12/13. Then do the math. A negative times a negative gives you a positive, 15. 55 times 13 is 65. Minus 48/65. This one gives you negative 33/65. Okay? So that was that one. Now I want you to do the tangent question. And I hope you're aware of the fact these are the worst. Okay? Let's give you 3 minutes to do that one. We'll pause the video and come back on in 3 minutes. 3 minutes. Do this one on your own. It's really important that you practice these. Okay, so here we go. This is, we're not going to do that last one. This is going to be tangent of alpha minus tangent of theta over 1, opposite of what I just wrote, multiply them together. Now, some of you, I know, get horribly mixed up when you're working with fractions. Let's see what I've got here. The tangent of alpha is, ooh, what did there? The tangent of alpha is negative 3/4. Minus tangent of beta. Be really careful with all these negatives. Negative 12/5. Yeah. Subtracting a negative. Then I've got 1 plus multiply. So let's clean this up. So we've got common denominator. What I'm going to do is I'm going to use the keep, change, flip technique. So I'm going to turn all of this into one fraction. What I'm going to use as the common denominator is 4 times 5. So this one needs to be multiplied by 5/5. This one needs to be multiplied by 4/4. So I've got minus 15, minus, subtract a negative, that's adding 48. That's what I've got in the numerator. I'm only using the keep, change, flip technique. Remember, I can only have one fraction. So here I'm something plus, oh, it's 1 plus. And negative times a negative is a positive, so that's going to stay as adding. 3 times 12 is 36. 4 times 5 is 20. And I want this to be one fraction, so I'm going to write this as 20/20 for that one. Okay, so now what I'm going to do is I'm going to keep, change, flip. So this numerator is negative 15 plus 48, negative 33. No, it's not, positive 33. Good grief. 33/20. And in the denominator, I've got, this denominator is actually turning out to be 56/20, and I've got to flip it. That cancels, and I'm left with 33/56. How many of you got that right? Type yay into chat if you got it right. Where did I get the answers, the values for alpha and theta, alpha and beta? I didn't. I don't know how big alpha and beta are. I didn't get an answer for alpha and beta. I got an answer for tangent of alpha and tangent of beta. I know the tangent of alpha is negative 3/4 because I did it up here. Yeah, here's alpha. This triangle describes alpha. a tangent. I don't know how big alpha is. I have no idea what the angle is. All I know is this triangle describes it because it ends on this terminal ray. I know the tangent is the y divided by the x, so it's -3 divided by 4. Same for, I don't know what beta is, but I know what the tangent of beta is. Big difference. Tangent is a y divided by an x, so it's 12 divided by -5, so it's -12/5. Okay? I do not know what alpha and beta are, but I do know what their tangents are. And I needed the tangent, not the angle. So that's what I was doing there. Okay, it was a great question, because I know a lot of people get confused by that. Right, let's move on. Oh dear, only 2 of you got it right. That's rather sad. Oh dear. Right. Now, when you do the card match tomorrow, you're going to want these. Okay? Let's have a look at what we've got here. Sine of A plus A. That's like sine of A plus B. Am I recording? Yeah. So that's like a sine of A plus B, but A is equal to B. So this is just the same sign sandwich. It's sine of something times cos of something, same sign, plus cos of something times sine of something. And all of them are A's. It's not going A, B, A, B. It's just going A, 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 A. Now look at what I've got here. I've got this plus that. They're the same. Remember that multiplication, 2 times 3, is the same thing as 3 times 2. When you're multiplying, order doesn't matter. You can switch it around. So I've got 2 things that are the same there. I've got 2 lots of, so 2 times sine of A times cos of A. They're the same. And look at what this simplifies to. I've got 2 A's in there. This is what we call a double angle identity. You're going to see this tomorrow and know that if you see this, it's equal to this. Okay? Let's do the same for cosine and tangent. This is like cos A plus B, but the B is just exactly the same as the A. So what I'm going to do for this one is I'm just going to write out the cosine identity. Cosines change sign. So I write cosine of something else, change it. This was a plus, so I write minus. Then I write the sine times the sine. Then just put in your angles, and we normally go A, B, A, B. This time we're just going A, 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 A. So what have I got here? Oh, they're not the same. This is something times itself, so it's squared. This is cosine squared of A minus sine squared of A. So that's what we call the double angle identity. This is the double angle, cosine of 2 times the angle A. If you see that tomorrow, know that it's the same as this. We'll be working with these double angle identities. They're called double angle identities. We're going to be working them in a lot more detail next week. We're not going to do much with them tomorrow. And for a tangent. Tangent of 2A. I won't write it there because it's a fraction, so it's going to be a bit of a hot mess first, isn't it? This is, you do the same as that's in there. And on the bottom, you do 1 and you do the opposite. If that was plus, this is minus, then you multiply them both together. Oops, got the A. Give the angle. So look in the numerator there, you've got tangent of A plus another tangent of A. You've got 2 times the tangent of A, all over 1 minus, and here you're squaring the tangent. Tangent squared of A. And that here is the tangent of 2A. So you're going to see this tomorrow. When you do, just recognize it's this. So highlight these in your notes. You're going to want them tomorrow. And next week, we do a lot more work with them. So I'm not going to teach any more today. So I'm closing the video off.